So, hi all, welcome back to Malware Analysis. I am J. Lavanya, Assistant Professor of CS Department. So, today in this video, we are going to discuss on the topic Unit 3, that is reverse engineering. So, the first subtopic we are going to discuss is that reverse engineering as a process. So, let's dive into the topic. So what is meant by reverse engineering? So reverse engineering malware is one such analysis technique that involves disassembling the program's components and functions to gain insight into its behavior, structure, and capabilities. So this process can assist cybersecurity professionals in recognizing the attack vector of a given threat, pinpointing its infection and propagation methods, as well as crafting some effective countermeasures. Okay, so these all comes under the reverse engineering. So in general, if I want to say some quick thing is that in the context of malware analysis is that it's dissecting malicious software to understand its functionality, purpose, and behavior. So this process is crucial for cybersecurity professionals to develop some effective defenses, improve some instant response, and enhance the threat intelligence. So by analyzing the malware's code and structure, experts can identify some vulnerabilities or develop some deduction mechanisms and create countermeasures to protect the systems as well as the data. Okay, and one of the steps to be involved in this process is the first step, setting up a safe environment. So before analyzing any malware, it's essential to create a secure environment, often a virtual machine, to isolate the malware from the host system and prevent it from causing harm. Okay. And second thing is that collecting some malware samples. So malware samples can be obtained from various sources like public repository, example like Virus Total, Honeypot, or through some instant response activities. And next one like static analysis. So this is the initial phase involved in examining the malware's code and structure without executing it. Tools like disassemblers and decompilers are used to understand the code's logic or identify some potential vulnerabilities and determine its functionality. Okay. And third one, like dynamic analysis. So in dynamic analysis, the malware is executed in a controlled environment. So this controlled environment I have already seen in the last video, the previous video. So example is that sandbox, okay, to observe its behavior, interactions with the system, and network communication. So this helps in understanding how the malware operates in a real time. Okay. And next one we are gonna discuss is that how to develop some countermeasures in this is the step in reverse engineering. So based on the analysis, cybersecurity professionals can develop some countermeasures like antivirus signatures, intrusion reduction system rules, and security patches to mitigate the threat. And what are the key aspects of this reverse engineering in malware analysis means? The first step, understanding the malware families as well as variants. So reverse engineering helps to clarify the malware into families and identify the new variants, aiding in predicting some future threats. Okay, and analyzing the attack techniques. So by studying how the malware interacts with the system and executes the attacks, security professionals can understand the attack vectors and prevent some similar incidents. Okay, and developing some deduction mechanisms. So reverse engineering helps in creating some deduction signatures, informing the development of antivirus tools, and enhancing some intrusion detection system and strengthening some system defenses. The knowledge gained from reverse engineering can be used to identify and patch the vulnerabilities, improving the overall security posture of the systems. Okay. And this is about the reverse engineering process in the malware analysis, some a short detailed diagram, right? So reverse engineering process in malware analysis first is that we have to understand the purpose, for which purpose we are analyzing this reverse engineering process in the malware. So what type of goals is involved and all those stuff we have to learn from this. And second one, like analyzing the interaction. So observing how the malware affects the system. So this is the steps we have to take in case of reverse engineering, right? And next one, some identifying some vulnerabilities. So finding the weaknesses in the malware and what type of threat to reduce these kind of steps, we have to just first I have to identify. And next one, like deconstruction, like breaking down the executable into some components such that this will be available in the various time component. Okay, so this is a simple step in reverse engineering process in malware analysis. Okay. Okay, so the next slide we are gonna see is that why to reverse engineer malware. Yes. So reverse engineering malware can be practically insightful for identifying some zero-day vulnerabilities in software, which are otherwise unknown to some respective software vendors and can be exploited by attackers to gain access to systems as well as some data. So analyzing the malware also enables reverse engineers to identify, exploit the code and vulnerability in exploits. Okay, and this reverse engineering malware can also be beneficial for mimicking the technique attackers employ to avoid the detection and propagate it. Although by employing some obfuscation or anti-analysis techniques, malware developers make it harder to analyze their code, reverse engineering the malware, which can identify these tactics and create some countermeasures which is designed to detect and prevent some future outbreaks. Okay, and apart from this, why the reverse engineering is possible or why it is required in the sense, because the main keyword or one of the reasons if you take like product improvement and innovation, and second one, understanding the competitive design, reverse engineering allows companies to analyze the competitive products to identify the areas for improvement in their own offerings, identify the design flaws. So by examining the existing products, engineers can pinpoint the weaknesses or the areas of potential failure, leading to more robust designs and creating sorry and creating competitive products. So reverse engineering can help in creating some competitive versions of products, potentially using some different materials or manufacturing processes and developing prototypes. It can accelerate the development of new products by providing a starting point for creating some prototypes and updating older products. So reverse engineering can help to modernize or update the outdated products by understanding their original design and adapting them to some current standards. And next reason, in case of some security as well as compatibility, identifying some security vulnerabilities, reverse engineering can be used to analyze the software and hardware for security flaws, helping to develop better defenses against the cyber threats. Okay, and ensuring interoperability, it can help in making different systems work together by understanding how they were designed and how to create interfaces between them. And recovering the lost data. So reverse engineering can be used to recover the lost source code or the documentation of software, enabling the maintenance and updates. And cost reduction and efficiency by finding some cheaper alternatives. By analyzing the existing products, engineers can find ways to use some cheaper materials or more efficient manufacturing processes. And understanding how a product is made can help in streamlining the development processes and reducing the cost. And other applications, if you take like a failure analysis, technical documentation, as well as manufacturing. So reverse engineering can help to determine the cause of a product failure allowing for some corrective actions, and it can be used to create some technical documentation when it's missing or incomplete. Okay, so this is why we are going for this reverse engineering malware. Okay, and next we are going to see is that techniques for reverse engineering malware. So as we have already discussed, there are two analysis techniques. First one, it's static analysis, and second one, like we have the dynamic analysis, right? So what are the techniques for or the choice of this analysis techniques? Mainly it depends on the type of malware being analyzed and information that needs to be gathered. So while both static and dynamic analysis techniques have their benefits and limitations, leveraging a combination of both static and dynamic analysis techniques, which is often the most effective approach for analyzing the malware. And if you take the static analysis benefit, it offers an insight into a structure and behavior of the program, which can be performed without executing the program and less resource intensive than the dynamic analysis. And what are the limitations when compared to dynamic analysis is that it cannot detect the runtime behavior, ineffective for analyzing the malware with some anti-debugging techniques. And third one, it may produce like inaccurate or incomplete code during some decompilation. Okay, and when to use. So for initial analysis of malware to understand the structure, logic, and behavior of the code, which is useful for reverse engineers who may not be familiar with the programming language used in the malware codes. Okay, and dynamic analysis, if you consider, it offers insight into the behavior of the program during runtime, which helps to detect the runtime behavior and interaction with the system, and ability to identify and analyze the anti-analysis techniques, and which is used to evade the detection. Okay, and what are the limitations if you take? It can be resource intensive and time consuming, and may not be accurately reflect the behavior of the malware on a real system. And when to use, if you just consider, so it will be most probably for monitoring the program runtime behavior and identifying some anti-analysis techniques for detecting some rootkits or identifying the malicious processes and finding some indicators of compromise. So for these kind of stuff, this techniques is used. And in general, if I just want to and elaborately if I want to discuss me. So a main thing of static analysis, it's the practice of dissecting the binary code of a malware sample without actually running it. So this technique helps in comprehending how the malware functions or its capabilities and what kind of damage it may cause. And there are three primary techniques which is used in static analysis. First one, disassembly. So this process transforms a program's binary code into some human readable assembly code and enables reverse engineers to decipher the structure and the flow of code. Okay. And for example, if a reverse engineer comes across a malware with an unknown payload, they can use some disassemblers such as IDA Pro or Ghidra. Yes, these kind of stuff or tools we have already discussed in the previous video. You can just check it out. And to examine this binary code and locate its entry point. So once it is identified, analysis of the assembly code can be provides insights into how the payload behaves. Okay, and this disassembly tools can also be employed to identify some malware packers, which uses some compression and obfuscation techniques to avoid the detection. And by disassembling the packed code with the disassembler, reverse engineers can decipher its functionality and create signatures for some future detection. Okay, and second one, decompilation, the static analysis. So this process converts the mission code of a program back into higher level programming languages such as C or C++ to make it simpler for reverse engineers to analyze the program's logic and structure. For instance, to reverse engineer the malware samples written in some obscure programming languages, analysts can utilize decompilers such as Hexray's IDA Pro or Ghidra to convert the mission code into a more familiar programming language. So once this code has been converted to something familiar, analysis of its behavior becomes much simpler. And this decompilation tools can be employed to detect the malware obfuscation techniques, which makes the code more difficult, okay, to read or to comprehend. And so by decompiling this code, reverse engineers make able to recognize these techniques and undo them in order to gain insight into its true functionality. And next one, like symbolic execution. This technique utilizes variables and symbolic values to simulate the execution of a program. And symbolic execution can be helpful in understanding how the malware code can interact with the system and change its behavior. For instance, if a reverse engineering comes across the malware that employs some anti-debugging techniques, they can use some symbolic execution to execute the code and circumvent these measures. After bypassing these safeguards, they can analyze the code's behavior to uncover its functionality. Okay? And symbolic execution tools, uh, these tools, it also can be used in some various employed to detect some zero-day vulnerabilities in software, or by running a program symbolically. Reverse engineers can identify some inputs that cause some certain code paths, leading to the discovery of vulnerabilities that could be exploited by the attackers. And next one, like dynamic analysis. So it involves executing the malware sample in a controlled environment to observe its behavior. So this technique is useful in understanding how the malware operates, what its capabilities, and what kind of damage it can cause. So there are three primary techniques which is used in dynamic analysis. First one, debugging and tracing. Second one, memory forensics. Third one, emulation and sandboxing. Okay. So first one, debugging and tracing. So these techniques are useful for recognizing a malicious control flow, detecting some anti-analysis techniques which is used to avoid the detection, and comprehending how the malware interacts with the system during runtime. For instance, when a reverse engineer comes across malware samples communicating with some remote servers, they can use some debuggers such as ODDBG to attach to the running process and analyze its behavior. Or by setting some breakpoints on network related functions, the reverse engineer can intercept traffic between them and analyze its content. So once collected the data that has been analyzed, they can deduce which communication protocol was utilized between the malware and its server. And tracing tools such as sys internals process monitor can also be employed to track the system activity associated with malware, and a reverse engineer can use such process monitors to monitor the registry and file system access along with network activity in order to detect any changes made by the malware and gain insight into its behavior. And next one, memory forensics. So this is a process of studying the contents of a computer's memory using some memory analysis tools and extracting the information of running processes or the memory dumps. And memory analysis tools are typically used for gaining some insights into the computer system's current state, and it can additionally be employed to detect the malicious processes and rootkits. Okay. For instance, if a reverse engineer believes that malware has injected code into an efficient process, they can use some memory analysis software such as volatility to identify the code and assess its functionality. With this approach, they can also have access to processes and DLL to load in memory. Plus, network related data that is stored there or instances where a reverse engineer believes there has been some installation of a rootkit on this system. They can use some recall memory analysis software to detect any suspicious processes or modules loaded in memory. Okay. And third technique, like emulation and sandboxing. There are powerful techniques that enables malware to be executed within a supervised environment, right? So in a supervised environment also, uh, they will be having some case of uh, techniques or the things where it has to be gained. So, okay. So in order to overcome such cases, they'll be using some or modules loaded in memory. And like in a reversing execution sandboxing also, they will be using some uh, environment like Cuckoo Sandbox to execute it and analyze its behavior. This provides a control setting that malicious code can be executed without impacting the host system. So once understood, researchers can devise some strategies to remove the rootkits from some injected missions. Okay, so this is all the techniques of reverse engineering malware. And next, we should discuss about the benefits of malware reverse engineering. So first one, like improved threat reduction. Second one, like enhanced instant response. Third one, strengthened security posture. Fourth one, improved threat intelligence. And last one, developing more effective defenses. So first one, like improved threat reduction. So by understanding how the malware works, security professionals can develop some more effective detection mechanisms. And like the second one, enhanced instant response. So here also, reverse engineering helps in understanding the attack vector and crafting some effective instant response plans. And third one, like strengthened security posture. Reverse engineering helps to identify the vulnerabilities and develop the countermeasures to protect the systems. And fourth one, like improved threat intelligence. Sharing information about malware variants helps the broader cybersecurity community to proactively defend against emerging threats. And next one, developing more effective defenses. Reverse engineering allows for the creation of more robust and tailored defense mechanisms. Okay, so these are the benefits of malware reverse engineering. And next one, these are the popular reverse engineering tools like it has the IDA Pro, Ghidra, OLDBG, X64DBG, Wireshark process monitor. So this IDA Pro is a powerful dissembler and debugger that supports a wide range of architecture and file format. And Ghidra, a free and open source reverse engineering tool, which was developed by the National Security Agency, a popular debugger for Windows executables. And X64DBG is an open source debugger for some Windows executables, and Wireshark, a network protocol analyzer that captures and analyzes the network traffic. And process monitor, this is a Windows systematic tool. We have already discussed it, auto and proc mode. We have discussed in the previous video. You can just check it out. And tools that monitors file system registry as well as the process activity. And then we have the process explorer and volatility. Okay, and uh, in case of real world scenario, how it is used, like consider a scenario in which a security analyst has identified a suspicious executable file on a Windows system which appears to be communicating with a remote server. The analyst suspects the file there is a trojan malware and wants to analyze to determine behavior and steps to remove it from the stem system. Okay, so what are the possible steps the security analyst will be doing is that first step, he'll be obtaining the executable file. Like the first step to obtain a copy of the suspicious executable file from the Windows system for analysis. Like .exe file will be stored, right? So he'll be just fetching that. And second step, he'll be performing the static analysis. So using a disassembler such as IDA Pro or Ghidra to perform some static analysis on the executable file. And this can include some disassembling the code to understand the program structure and behavior and identifying any obfuscation techniques which is used by the malware to evade the deduction. And next one, like perform the dynamic analysis. The analysis also use a debugger such as OLEDBG or X64DBG to perform the dynamic analysis on the malware. So this can include some debugging and tracing the code to identify how the malware interacts the system and any anti-debugging techniques which it may be using. And next, like monitor network traffic here be the next step. So using some network analyzers such as Wireshark or a TCP dump to monitor the network traffic which is generated by the malware. This can include identifying the IP address of the remote server, the malware which is communicating with, and the types of data being sent and received. And next one, identify the malware functionality. So based on the information gathered from static and dynamic analysis, the next step is to identify the malware's functionality, such as analyzing the amount of damage which can cause and how it communicates with the command and control server and whether it uses any rootkit or anti-deduction techniques. And next one, like developing a remediation plan. So like post analysis, develop a remediation plan to remove the malware from the infected system and prevent it from spreading to the other system. And this can include updating some antivirus software or patching vulnerabilities exploited by the malware. Okay, and educating the end users on how to avoid the malware infections in the future. Okay, so this is all about the real world scenario. So in this particular video, we have discussed about the what is meant by reverse engineering and why this reverse engineering is used in malware and what are the types like static as well as dynamic analysis. Okay, and we have seen the real world scenario, some possible steps, right? And we have discussed on the benefits of malware reverse engineering. Yes, and what are the steps to eradicate this or reverse engineering, right? And in case, so it's a complex, right? Reverse engineering malware, we can't able to say it is very easy. It's a complex task that requires some technical expertise and use of some specialized tools, right? So by using these kind of analysis techniques and tools, we have some additional points to reverse engineering. So ensure that you have some appropriate technical expertise. And second one, you should work on these conduct malware analysis in a secure, isolated environment. You can use some sandbox, right? And you can use some multiple techniques to get a complete picture of the malware behavior and functionality. And you have to stay up to date with the constantly evolving tools and techniques that's used for some malware analysis. Okay, and you have to keep some detailed notes and documentation of the process of information she's sharing and replicating the analysis. Okay, so by means of this, you can able to get a clear idea of reverse engineering the malware concept, right? I hope this video will be very useful. We will see in the next video. So thank you all.